This playlist collects together the modules of the first of 2 lectures on native human inference abilities and their complementary formal systems. We'll start off by characterizing inferences, talking about what they are, talking about what important properties they have, and so on. Then we'll turn our attention to 2 elements that really strongly shape native human inference ability: the brain's architecture and its inference strategies. Then we'll focus in on those inference strategies and their typical deployment. After that, we'll turn our attention to focus on native human deductive inference abilities and their complement in formal deductive systems like predicate logic. Then we'll turn our attention to inductive inferences and the formal systems that have been developed as alternative strategies for solving problems in inductive situations. We'll end the lectures by focusing on judgment heuristics for inductive inferences from the cognitive psychology literature. So let's start with the first component here. Let's talk about characterizing inferences. We'll talk about how pervasive inferences are in everyday activities. We'll give a characterization of inferences as psychological processes that transform information. We'll talk about some of the important functions that inferences serve in cognition, and some of the goals that one might aspire to or want to optimize with one's inference strategies, and whether or not they can be simultaneously optimized. Then we'll turn our attention to those 2 elements that so strongly shape native human inference ability: the brain's architecture and the sorts of inference strategies that it involved to deploy. We'll begin with working memory capacity, focusing in on the severe limitations that are placed on conscious problem solving by the size of working memory. And we'll talk about how working memory places a limit both on the amount of information that we can use in conscious problem solving and on the complexity of the information that we can use in conscious problem solving. Then we'll turn our attention to more generally looking at the evolutionary origins of native human inference abilities. We'll be looking at that 4.4 to 7 million years of human and proto-human evolution, during which time human beings lived in almost exclusively hunter-gatherer existence, a hand-to-mouth existence. We'll look at how that shaped both the kind of environment that humans evolved to solve problems in and the sorts of problems that humans evolved to be good at. So when we think about inferences, we tend not to think about inferences in terms of semi-conscious or unconscious inferences. And because we do that, we tend not to think of how pervasive inferences are in our everyday life. So for example, suppose that you're walking in the quad and you see your friend from your critical thinking class. Well, already there have been a number of really complicated inferences that have gone on. Your visual system has taken the light that was reflected from the visual scene onto the back of your eye, and it's made several very complicated unconscious inferences in order for you to recognize your friend's face. Once you recognize your friend, you may remember that you have a test next week, and you may make several semi-conscious inferences in order to walk over to them and ask if they want to study with you. So you may consciously form an intention to do so, but you'll unconsciously determine the direction in which you'll walk through the crowd. You may consciously ask them or talk to them about how their day is going, but unconsciously you may be monitoring how close or far away you are from them, exercising all sorts of social cognition. When you and your friends study, you'll probably use strongly conscious inference strategies. Say, for instance, you consciously use the truth table method to evaluate the validity of some propositional logic practice problems. In all of these cases, inferences are psychological processes that transform information that's available and explicit to the part of the brain that's making those inferences. And does so with the goal of creating new information that is available and explicit for that system or for other systems or for use overall. So it works to create new information, previously unavailable information. For instance, this is a specialty of induction. Or to take information that wasn't explicit and to make it explicit. That's also a specialty of deduction. You still may be a little unclear about that distinction between explicit information and inexplicit information, and the distinction between available information and unavailable information. Well, remember in the last chapter, I discussed that distinction using the bank analogy. Granny sends you a check for your birthday and you deposit the check, but the money isn't immediately available for you. You can't get a hold of it. And so as a result, it's unavailable, monetarily unavailable. In a few days, then the check clears and it becomes available. The same thing with information in our brain. So if you can't remember, say, the name of one of the judgment heuristics that we talk about when you're taking the test, that information is unavailable to you at the moment. But then you may later on say, oh, I remember now. Now it's become available to you. Similarly, when we said that you went to the bank and you withdrew some money from your account and they gave it to you in euros, that was the financial equivalent of inexplicit information. It's money, but it's not money that you can actually use. It's not something that Ralph's will accept if you want to go buy groceries. If you then give that money back to them and get US currency, now you've got financially explicit information, that is. You've got money that you can spend. And the same is true for information. If information is encoded in a way that doesn't allow the system or process that wants to use it to exploit that information, it is said to be inexplicit. When it is coded in a way that your brain can use, then it's said to be explicit. Let's go back and think about that finding your friend on the quad example. Unconsciously, your visual system has access to information about the environment because light that is reflected and projected from the visual scene falls in the back of the eye, and the photosensitive cells at the back of the eye then transform that information into neural signals. That information has now become available. Moreover, because your brain has evolved to use that information, it's also explicit information. Now, what isn't explicit in the reflectance patterns in the back of your eye are things like what the shapes, the objects, and the distance are. Your brain has to reconstruct all of that information. It's inexplicit. It's not represented there in a way that can be utilized. And so your visual system has to process that information to create that. Same thing would be true with your semi-conscious reasoning. You may form an intention to go and talk to your friend. And when you do, that intention pops up or is available in working memory. Before you actually form that intention, you probably unconsciously already made a decision about that intention. And when you wanted to walk over to see your friend, you definitely unconsciously already planned a map to how to get to them through the crowd, right? So information will be explicit and available to particular systems or processes in your brain, not to every system or process in your brain. It may be only unconscious. Part of it may be conscious. Some of it may be completely conscious. But in each case, when information is explicit, it's encoded in a way that that system or process can utilize it. And it's available when it's there for the system to use, and unavailable when it's not there for the system to use. So different parts of our brains are going to be getting access to information. It's going to become available to them. If it's available to them in a format that they can use, it becomes available and explicit.